Good. Yeah, so thank you guys for joining this session. This is a meetup, which is an online meetup we have been doing from last 2.5 years kind of a thing. And we have been discussing different Kubernetes topics and CNCF topics over the years. And it's a privilege to have Vaidik and Laurent in this session in which they're going to share their knowledge in running Kubernetes in production, and of course, how to save the cost on cloud, which is, I think, both the prominent things are there, right? So Vaidik is an experienced engineering leader and have been kind of working in this space for a long time. And currently he is doing freelancing and helping startups to reimagine the approach of deliveries, operations, DevOps, and so on. And we all know from his previous blog, which he wrote for Blinkit earlier, in which he kind of dig deep into how the experience of running K8s on production. I think you would have seen it, but if not, that's okay, because Vaidik is here and we'll dive into that further. And then we have Laurent from Cast AI, which is a Kubernetes automation and cost optimization platform. And I just kind of going over the profile of Laurent and just saw that like he has done many startups earlier and sold to Oracle, Google, and maybe others as well. And so many degrees he has. So I think it's our really honor to have him here to kind of discuss further on the topic, what we're going to cover. So with that, I'm just going to hand over to Vaidik. So we'll start with Vaidik's session for around 40 minutes. And after that, we'll have Laurent to discuss about the cost optimization on Kubernetes. Yeah, so over to you, Vaidik. I'm just going to unshare the screen and give the access for you to share as well. Yeah, go ahead, Vaidik.
Thank you, Nipendra, and thanks a lot for that introduction. Just give me 1 second while I set up my screen. All right, can you confirm if?
Yes, very much. If we can see that and audible, yeah, all good.
All right, awesome. Well, hi everyone. I'm super excited to be here. It's been a while since I've attended a meetup, but I'm really glad to be back. Also, we don't get the chance to meet face to face these days. But it would be really nice if if people can, if you're comfortable, if you could switch on your video. I think that just makes this session much better. Both for the speaker as well as the rest of the community, so that
please make sure nobody's sleeping, Vaidik.
Yeah, no, that's all right. I mean, when I go on calls, I just set that expectation that hey, I'm at home.
Of course,
I could be dressed fine upwards, but I could be on my boxes. So I'm cool with that as long as you're cool with it, right? So cool with it. Just switch on your video.
But you can share the presentation for a while so that we get a larger view of everyone. You can unshare the screen for a while.
Yeah, just a second.
Yeah, it's definitely good to have view of everyone.
Well, whoever turned on their videos, thanks a lot.
Yep.
I always feel inadequate because mostly everybody has hair, you know.
I don't know. Maybe hair is also overrated, right? Like it turns like you don't have hair, you don't have a color problem now.
Right? Well, true.
I have a cap, so it's okay.
Well, thanks a lot, guys. Thanks a lot for sharing your, for turning on your videos. I'm going to go back and share my screen again. Just give me 1 second. Can you guys see my screen now? Yes?
Yes, we can. Yeah, all good.
Cool. So yeah, hi everyone. Once again, I'm here to talk about Kubernetes today with you all, particularly as Nipendra had put in the poll about day 2 operations of Kubernetes, or sort of like Kubernetes beyond the technology that excites most of us to get onto it, right? Of course, Kubernetes has got a lot of attention over the past few years, and there are very good reasons behind it. At Blinkit, we decided to migrate to Kubernetes almost 3 years back, or maybe a little more than 3 years back. Today, I'm going to talk about why we went in that direction and how it worked out for us. I wrote a blog post about this on our tech blog, and it received a lot of attention. So some of the things I wrote about, I felt still continue to be true and are worth spreading to as many people as possible. So I thought it might be a good idea to talk about the same thing today. And I instantly proposed the same topic when I was talking to Nipendra. But when I sat down to make these slides, I realized that I wrote the post almost a year and a half back. So it's actually been more than 3 years since we have been running Kubernetes in production. And so, yeah, just today morning when I was building my slides, I realized that I have a surprise for you. And that surprise is, well, I'm not going to talk about just 2 years of product experience, but actually 3 years of production in Kubernetes. A lot has changed since when I wrote the post, and a lot has changed in the world, a lot has changed in Kubernetes. And a lot has changed in my own abilities to interpret our experiences and reflect back. So while this presentation builds upon my blog post, there's some differences that I've highlighted, and I'd like to share those with you today. But a little bit about me. So I'm Vaidik. I currently work as a freelance technology consultant, primarily working with startups and scale-ups to help them with their technology strategy, building products, coaching their teams, supporting them in the capability of a technology leader. Before this, I spent almost 6 years at Blinkit, or formerly we were called Grofers, where I did pretty much everything an engineer could do. So infrastructure engineering, back-end, front-end, and eventually moving into a leadership role where I led the DevOps and platform engineering group. Before that, I spent about 2 years at another company called Wingify, which is a B2B SaaS company based out of India. And today, I'm going to be specifically talking about our experience of running Kubernetes at Blinkit, right? But beware, these lessons and experiences are meaningless without context. So I am going to tell you a story first before we dive into the main lessons that I want to share with you, because this story is important for context, right? So here we go. So quick one about Blinkit. It's one of the largest online grocery services in India. Hopefully you use it. Been there for around almost 10 years. Started as hyperlocal marketplace, so grocery stores where customers can order online and get their orders delivered in 90 minutes. And there was a need for a convenient service like this in India, and we were solving that need. And we grew rapidly back in the day, right? But like as most startups, we started with the crazy idea, faced multiple challenges along the way. We changed our core value proposition multiple times. We changed the business model multiple times along this entire journey. And each of those changes were pivotal in our journey, right? It's completely changed how the company sort of worked. The changes were almost that big that it was sort of hard to even say that how did you go from this place to this place and place, right? So they were tough, but we would not have been able to survive if we were.
Blinkit की story सुना रहे.
Sorry, I think somebody needs to turn off their mic. It's probably Abhishek, perhaps.
Yeah, sorry. My mic was on mute. Sorry.
No worries. It's all right. So yeah, we wouldn't have been able to survive and be where we are today without the tremendous agility we built in our tech systems, right? And we realized that agility and speed as a tech team is one of our core strengths for us to continue to be relevant in the business and continuously keep creating value for our customers. So pretty early, we realized that giving the power to our developers to make their own technology decisions will be vital for our agility. We pushed the idea of developer and team autonomy as far as we could, adopted you build it, you run it philosophy, and enable teams to take their own technical decisions, manage the entire stack, including infrastructure and operations like config management, scalability, resilience, incident management, all by themselves, right? And DevOps teams were primarily responsible for taking care of governance, for providing processes and tools for developers to really own the entire application lifecycle by themselves. So to be truly independent, right? And before Kubernetes, we were deploying everything to EC2 instances directly. So we were primarily on AWS. We were using Ansible, Jenkins. Common tooling was mostly standardized, but not logged. So if anybody wanted to sort of deviate because they had a really strong reason, they could do that. And this setup led to a very diverse stack that grew organically, right? public cloud made this autonomy possible to quite an extent. We realized that if we are on the cloud, we should use the benefits of the cloud. And then we moved to Kubernetes about a little over 3 years back. And here's what we've done with Kubernetes at a high level in these last 3.5 years, roughly. 90% of our target production services are migrated to Kubernetes. By target, what I mean is that we never intended to migrate everything to Kubernetes, especially like stateful services or some services that were, legacy services were extremely slow moving. We were not really changing much there. And there's a lot of benefit that comes when using Kubernetes for development and CI/CD. So we practically now develop in the cloud. Developers treat the staged Kubernetes cluster that we have as an extension of their laptop. So complex integrated dev environments with, even more than 20 microservices can be created by anyone really in the team on demand under 10 minutes, right? So we don't have like perpetually running environments like a dev environment or a stage environment. People create new environments and destroy them as they're needed. And what it means for developers is that we use a combination of tools built on open standards that work well for specific purposes, but at the same time, we limit them as well. While we have moved to Kubernetes, we still continue to use Ansible-based tooling for certain old workloads or even new workloads where it still continues to make sense to use Ansible. And the larger scheme of things, platform teams continue to build abstractions that reduce ops overhead and improve the developer experience for our developers. So anything to do with cost, security, reliability, we used to make them available as tools that developers could quickly adopt without a lot of cognitive overload. And it took us a couple of years to get to this, right? A couple of years, a lot of engineering time from product and platform engineering teams, and a few hundreds of thousands of dollars to get to this state, right? So this is a fantastic place to be, but this was the cost of it. It was a big investment. And the question I keep sort of asking myself is, was it worth it, right? The pain we went through, was it worth it? So to answer that question, again, we have to go a little back in time and to sort of like debug why did we do what we did. In early 2018, we realized that we had an illusion of agility. So while we were always targeted towards building a team and a culture for speed and agility, in 2018, we realized that a lot of it was just an illusion of agility. Teams were working independently on their microservices, deploying multiple times a day, but there are not enough guardrails for quality, right? So we were creating a lot of waste, shipping poor quality products. They were frustrating customers, frustrating internal users, frustrating management. Our engineers were burning out as they were busy firefighting and instead of shipping value to customers. We used to think that solving just for infrastructure orchestration, infrastructure management, delivery pipelines is enough. Saying you build it, you run it, and our teams will take care of quality, write tests, and do the right thing all the time will just happen. And to an extent, it happened as well. However, what we ended up very quickly was a proliferation of microservices that teams created to manage technology within the boundary as they understood, right? And more often than not, the teams are not considering the impact of introducing new microservices on the overall architecture. We ended up with autonomous teams creating microservices independently to solve problems within their boundaries and under their control. But due to the missing guidance of an overall architecture, we ended up with microservices that were hard to develop, test, release, and monitor in production, right? All the values that you are ideally get out of a microservices architecture, we were not getting there. In many cases, the boundaries were not clear enough, leading to slow releases, features being developed across microservices. Our quality feedback loops are so poor that sometimes you are getting to know about the bugs directly from customers, customer support, and even directly from CEO, right? And we realize that this is unacceptable. This is just not going to work if we continue to work like this. And the lack of technical oversight made this microservices architecture extremely complex. While the infrastructure level processes were decently managed, application releases were manually tested, orchestrated. Testing for certain kinds of behaviors was just not possible. Whenever we try to approach testing microservices, we would not be able to make any meaningful progress, as testing any one microservice was not enough from a functional perspective. And our microservices lost their well-defined boundaries over time. So we figured out that we were now dealing with what we internally called a distributed monolith that had become hard to reason about from a technical perspective. So in all of this, one lesson we learned was that if you allow your teams to launch more components autonomously and independently through self-serve tooling, I mean, it's great, and they will do it because developers want autonomy, because they want to be able to chase the goals that they want to chase. But if there's no framework to surface problems in your architecture, if there are no guardrails, if the practices are not well taken care of, the complexity will become too hard to comprehend, and it will become too hard to catch up. And more mess will just pile on, which is essentially what happened with us. So our developers were pretty unhappy because of a poor developer experience. Now, not from a tooling perspective, but from an application perspective, code quality perspective, test experience perspective. They were regularly dealing with bugs and incidents in production due to lack of testing. It was a very stressful atmosphere for us as a team. So in March 2018, we decided to slow down and to find a viable way to move forward and ship fast enough without continuously compromising on quality and resolve the mess we had created. And since our microservices are not really independent, independently testing them was not enough. We decided to run automated regression tests on our distributed monolith to ensure that a change in any microservice should not break the entire production experience or the customer experience, right? Which essentially meant running behavior tests on the entire backend for every little change that we were making. Our bet was that this would help us increase our deployment frequency again without compromising on quality. At the same time, it would give us a safety net to fix the architectural problems that we have, because as we re-architect, of course, we don't want to introduce more regressions. We call this initiative Project Ship It, and we felt like we knew how to get where we wanted to go. And we started experimenting with Docker and Docker Compose to build an on-demand CI environment in somewhere in March 2018. In about a month's time, we could orchestrate our complex backend and run tests over it, but it was all too slow and unstable for any real use, right? If we actually also asked developers to use it, they would have gotten even more frustrated. So we made efforts to finally stabilize it, make it performant, got to some acceptable level of stability to give us the push until we realized that we now have a new problem at hand, which was dev prod disparity, right? In production, we were using Ansible-based configuration management tooling, but in our CI setup and our state setup, we were using Docker and Docker Compose. And this often led us to see that the tests are passing in CI, but deployments were causing outages and bugs in production, right? So the classic problem of, hey, the test passed, but it's not running in production. And finally, in September 2018, we realized that our tooling is just not going to work. We are building container orchestration with a tool that was not built for local, development, and we needed something production grade. The industry's momentum was towards Kubernetes, so that's where we decided to go as well. And by Jan 2019, we had put a few critical services in production to prove scale internally first that we could do this. And this was the time when there was no EKS, at least in the region that we were operating out of. We had to use K8s to set up the cluster ourselves. Finally, by March 2019, we started migrating away from Docker Compose-based CI setup and started using Kubernetes for CI, and also started migrating the same services into production so that we can maintain dev prod parity. And we were finally on the path to running end-to-end tests on a stable CI environment with dev prod parity, and also reusing this tooling for streamlining local dev experience. So this is how and why we started using Kubernetes. We moved to Kubernetes for a better dev experience and for solving specifically our CI/CD problems, right? And this is the context that I wanted to share with you. So while we migrated to Kubernetes, we didn't migrate to Kubernetes just because we wanted to migrate to Kubernetes. We had a very clear reason. Our goal was to release high quality software while being able to re-architect independently. And that is what pushed us to adopt Kubernetes. And there was a journey to it. We tried Docker Compose first, it completely failed. but the process of this entire evaluation migration was quite complex and expensive, as we saw earlier. The learning I want to share here is be clear of your reasons before you move to Kubernetes. Is it more agility or better reliability, like faster auto scaling, resilience, streamlined operations, or automated incident management to an extent, or cost optimization, perhaps? Be clear of your reasons and align them to some higher level business outcome instead of just doing Kubernetes because that is the new cool thing to do, right? The interesting thing that is there with Kubernetes is it may not be the only way to achieve all of this, right? It's most likely just as much possible to do a lot of these things with your existing infrastructure today as well. Kubernetes does make these things easy to do because it has a lot of primitives built into it to adopt modern engineering practices. But the world has existed before Kubernetes as well, and so it is a good idea to sort of also think about that and evaluate that as an option, right? And there are still a lot of high performance engineering teams, big companies that still don't use Kubernetes, but have fantastic products. And there are many names out there that if you start to Google, you'll find. So it comes down to this, is that the amount of effort you may have to put in with your existing tooling, which could be quite significant, but at the same time, even migrating to Kubernetes is not cheap. It will require you to pretty much rebuild everything that you have built over the years with your DevOps team. And so the call is really between redoing everything that you have done so far versus committing to improve your existing platform, right? And we committed to Kubernetes, of course. But was it worth it? Absolutely. I think the place where we got to was fantastic. It pays us off in so many ways that, if we did not have this tooling and this way of development, we just couldn't have scaled our business the way we could. We get value out of it every day. It has made so many things so much simpler for us. It has opened more options for future. But I think that question is also incomplete, right? The right question is, did we go about adopting Kubernetes the right way? And the answer to that question, when I reflect back on our experiences, that I have mixed feelings about this. It took us about a year and a half to build a baseline Kubernetes platform at par with what we could do on EC2 and Ansible, and be able to provision our complex, messed up backend on demand for developers under 10 minutes. So we did achieve the goal of faster CI loops and safer releases, but rolling out Kubernetes in production for achieving dev prod parity made the problem a lot more complex, right? There's one thing is use something for CI/CD and local dev experiences. The other thing is you put it in production. And running Kubernetes in production is not straightforward, even with managed services like EKS and GKE. So we start believing that our journey from Docker to Docker Compose to Kubernetes was obvious progression into the container world, and the only way to solve the only way for us to solve our problem. We never really cared to look back and reevaluate if we really needed Kubernetes or containers at all to solve our problems. In retrospect, we could have just taken two tracks, a short-term track, probably a quarter of time to build on top of our EC2, Ansible, and console-based setup, streamline our usage of service discovery, speed up Ansible, build some Glue tooling to spin up new VMs for every developer to set up their complex microservices environment on it. This would have not been an ideal experience, but it would have most certainly worked. And again, in retrospect, when I check with people, friends in the industry, there are companies that do this kind of stuff. And the other track could have been a more long-term track would have been that we could have taken to build a rock-solid Kubernetes platform to simplify operations and get rid of this complex in-house tooling, bring stability, operate at low cost, and most importantly, build on open standards instead of building a ton of in-house tooling that was gluing things together. And we had to do a lot of that because still the Kubernetes ecosystem was evolving and a lot of tools were just missing. So we went through a ton of complexity, which honestly couldn't have been avoided if we were migrating to Kubernetes now or in the future. But we didn't care to evaluate if it was time for us to look into it at that point of time. Point being, Kubernetes comes with a lot of benefits, ranging from developer experience to operations, to better cost, to security, to governance. But does your company really need all of it? And does it really need right now? There's usually a way you can even find yourself to believe that it will help even right now if you go for it, because it will. But then does your company need it now with, I don't know, whatever priorities you have as a business and whatever cost constraints you have in your business? It's a really big undertaking, right? So if you do feel the need to adopt Kubernetes, you have to adjust your mindset a bit also before getting onto it. Kubernetes in itself does not solve any problems unless you understand what it really brings onto the table, right? If your teams are accustomed to doing things manually or infrastructure management is siloed between devs and ops, Kubernetes may not help at all, or it could even make things worse. Right? If your plan is to have a DevOps team that is writing manifests for developers and then making every little change when developers need it, you still have a silo problem. Technology is not really going to solve anything. To a large extent, there's an overlap with problems when migrating to the cloud from on-premise. So the principles of cloud adoption apply onto Kubernetes adoption as well. For some teams, adopting cloud engineering practices before migrating to Kubernetes may be a better approach to get the taste of operations and automation at scale, and to truly appreciate the abstractions that Kubernetes can bring, right? The next one is operations on Kubernetes is different in its own way. There's a steep learning curve for your cloud engineering and your development teams. Well worth it. Sorry, I think there's somebody else again on the mic. Okay. But yeah, it is well worth it for your teams to go through the curve to unlock the full potential of Kubernetes. We've first invested in the infrastructure platform team to learn about Kubernetes and the paradigm. We'd set aside learning sessions, sponsored trainings, Kubernetes certifications, which also, by the way, are a great way to learn about Kubernetes. But soon we realized that even having the engineering leadership outside the platforms group, which was my group, with some senior engineering leaders would have paid off in having them understand the paradigm faster and could co-build the Kubernetes platform internally with us that was suited to our business needs. So the adoption also would have been much faster if we did that. Doesn't matter if it is Kubernetes set up by your team or on bare metals, or if it is a Kubernetes set up by a major cloud provider. Out of the box, Kubernetes is just never enough, right? If you think that you'll set up the cluster and now you're ready, that's never really going to be it. Kubernetes is more like what a Linux operating system is for VMs. So you have to configure it with all the bells and whistles to suit the needs of your teams and your business. And that also takes quite a lot of time. If you think that dropping in Kubernetes and migrating applications to it is enough, you're going to struggle quite a bit later. The collection of components in the Kubernetes ecosystem tied together to craft a certain kind of developer experience is what makes a PaaS, not Kubernetes alone. One example of an opinionated Kubernetes distribution is OpenShift by Red Hat, which comes with a lot of components pre-configured. Another one is VMware Tanzu. For some teams, it may really be worth it to explore those options instead of setting things by themselves. So for example, one of the mistakes we made was not to figure out our ingress setup and directly use AWS Elastic Load Balancers for every application instead. Might seem like a dumb mistake now, but back in the day, these things were just like, that advice was just not available, right? So we learned these things in the hard way. And while getting started, it was very easy for us to just use ELB because we understood how ELB works. This led to a high number of load balancers very quickly and high operational cost due to applications that were not getting as much traffic in production, but were still spinning up ELBs. And the costs were even higher in staging and development environments where we were spinning up load balancers for non-production environments, increasing by a factor of number of active developers in a day, right? So every developer would have their own environment. Every environment has X number of services. So you can calculate how that grows so quickly. And while building a Kubernetes platform, we realized that a lot of factors like that you have to figure out, how you sort of what you end up deciding And how you end up deciding depends on your business context. So when talking about the bells and whistles, there are tons of things to take care of. I'm sure I've missed out some things in this list. And each of these things on the left were the decisions, again, I could remember that we had to make. And each of those things on the right are the corresponding solutions that we chose in our Kubernetes setup. Special mention for a decision to make is about managing Kubernetes costs. We're going to talk about that after my session today. You're going to lose visibility big time because the standard cloud cost optimization methodologies and tools just don't work. You will need specialized tools. Back in the day when we were doing all of this, there was nothing that we could use. These are good times. We have things like Cast AI that you can use. But back in the day, we had to build all of those things ourselves. Another special mention is for training, right? Kubernetes is not just for DevOps teams and SREs. It impacts everyone in the engineering team. So how will they learn and get productive quickly? You must think about that, or your execution will slow down, your rollout will slow down. You'll find a ton of tutorials, posts, conference talks showing what is possible with Kubernetes, but almost none of them account for legacy applications, which most likely do not closely follow the 12-factor pattern or the cloud native patterns. This can be really limiting. We found ourselves balancing between changing our applications or giving up our vision of an ideal platform. Doing both most likely would mean more time and higher cost. So this becomes a big challenge, right? If you're not using Kubernetes right now and you already have applications that are running, you should put in effort in thinking if the recommended components and solutions out there how will they play with your applications today? And if adopting those is hard, then you will have to make some trade-offs. So let's say you have figured out what your Kubernetes setup should look like, and you now have a cluster working with a couple of example applications. How do you get it adopted and migrated? We had an interesting challenge. Even with the blessings of our CTO and the teams taking up quarterly goals to migrate their applications, nothing would really move. We were really slow with our migration. We would struggle month after month with getting any serious traction to migrate any microservices to production. Managers and teams would start a new quarter over and over, but not make any significant progress taking their workloads to production. So we would even come as close to writing some manifests and completing training courses, but whatever we would expect to achieve would not get done. And we were really getting frustrated about this. So on digging for the reason, we learned a bunch of things that we had taken for granted while undertaking a transition of this complexity and scale. While everyone agreed to migrating to Kubernetes, only most of them actually agreed superficially. And it's not that they were lying, it's just that our teams did not, and it was also not that our teams did not want to explore Kubernetes. But when the teams got closer to execution, they were not able to see the value clearly in migrating. The path to getting value involved migrating 20 most critical microservices by 5 teams that were also working on new features. Doesn't matter whose blessings are behind the project. It was impossible to get any of our teams to do anything unless they're clear about the benefits of something, because it's a big risk that they're taking in production, right? Like I said, the first version of our Kubernetes setup was just as good as our EC2 setup. The risk of change was too high. The value was unclear. Even an exciting, cool new tech was not enough. Was not a value enough to migrate. So the value enough to migrate is essentially a significantly better platform, which can bring some value, either more reliability, better dev experience, better observability, better CI/CD capabilities. And that is the best incentive to create motivation within developers and teams to take that risk. The debate will always be about balancing value versus risk. We expected the teams to learn Kubernetes using popular online courses, which we had shortlisted, while delivering product features, which usually get a lot more attention than a migration project. To support our teams, we offered office hours, but that didn't seem to help. It wasn't very effective. Absence of adequate migration and post-migration support also introduced fear of what might happen when something goes wrong in production. Right? So we feel we could have done a much better job of providing that proactive support and managing that migration project centrally, making sure that all the necessary support is there with the teams, even from a knowledge and skill perspective. And while we were confident on Kubernetes overall, there were things like service discovery, config management, immutability of infrastructure that we had to figure out how it will all work for us. That made us run parallel stacks in production, which brought another level of complication in terms of technical decisions and operational challenges. We had to support existing tooling to deploy changes to both the stacks. You can imagine how complex that might get. One pipeline deploying to EC2 using Ansible, another one to deploying to Kubernetes. And then we also had to support rollback from both the stacks as well, right? Monitoring became complex as well because your monitoring stack was sort of split between these two infrastructures. When we started migrating to Kubernetes, AWS did not have, like I said, a managed Kubernetes service in our region. So we had to self-manage our cluster. It was a nightmare. Getting started was may not be as hard, but the real issues come when you deploy workloads. It's the day-to operations that matter. We had issues ranging from the cluster not auto-scaling at the right time to overlay networking issues to unreasonably high DNS latencies, which we could never figure out why that happened until we upgraded core DNS. We had seen a lot of these painful issues, a lot of these war stories, especially with networking, because our team is not an expert of networking, right? We didn't want, and we neither wanted to become an expert of networking. So we always recommend going for a managed Kubernetes service instead of doing setting things up yourself. But even with managed services, you have to worry about upgrades, you have to worry about cost of workloads, you have to worry about security, you have to worry about governance. All of those things become extremely important in how you set up and operate your cluster going forward. So speaking of embracing the new paradigm, the core concepts of CRDs, operators, controllers, admission controllers, mutating webhooks are all important concepts to really push a Kubernetes platform to provide a superior experience. These concepts allow platform engineers and operators to build abstractions over existing processes to make infrastructure management more declarative, streamline operations for developers. And if you're not there, I'm not saying that you will not get value, but true value gets unlocked when you actually start adopting the paradigm. So we feel that Kubernetes is great, but it's even better when you're using these features to simplify daily operations. So for example, we used to use CRDs to turn some of our workloads to a more declarative style of infrastructure management. Today, we have a handful of use cases specific to our setup that we have abstracted using CRDs and custom controllers. Many governance and security policies are built into admission controllers and mutating webhooks. All of these things make our lives as a team much easier, right? With the abstractions built over Kubernetes, developers also get a more consistent user experience, right? So if you're using, for example, a CRD or a controller to drive a platform capability, now you're not giving your developers another tool that you have built in-house, which has to work alongside the Kubernetes way of doing things. And that ends up becoming a much better developer experience and Kubernetes experience. So while I've shared what we learned from our journey, there's a lot of value in doing all of this. I want to remind you to ask yourself if all of this is necessary now for your business. Do you have the liberty to make a long-term investment, or there are more short-term priorities that must be addressed first? Can you find a middle ground with your existing stack instead of delaying value by making an investment this big? That's the decision that you as practitioners must make. But let's say for some reason you're clear that you have to move to Kubernetes for whatever reasons, right? I would not recommend you to do everything yourself. Don't do it like the way we did it at Lincoln. Unfortunately, we did not have many options back in the day. The ecosystem was not mature. There were not many managed services. We did not even have access to experts who could give us the advice on how to do this. So we had to do everything ourselves and learn everything the hard way. But if I were to do it all over again today, I would not follow the same way. I will most definitely do least amount of work myself and rely on external experts to do most of what Jeff Bezos calls undifferentiated heavy lifting by someone else, by an expert. So let's quickly look at what options you have if you were to do all of this today. The ecosystem has become mature. It's becoming better really fast. There's no reason to not try these options and make your life easy. So again, everything on the left is a list of decisions you have to make. Again, it's not exhaustive. Some of the things I've left on purpose. And everything on the right is a managed service solution available today that you can explore. Of course, that is also not exhaustive. These are just some examples. And I'm clearly being nice to the sponsors to give them the visibility because, well, we are able to meet here today because of them. I'm not associated with them in a professional capacity, but yes, they're friends. And most importantly, they're all doing great work in this space. I have first-hand experience with that. So the team from Devtron, Cast AI, Cloud Yuga are all here. Please go speak to them about your Kubernetes challenges. But these are all paid solutions, right? And as developers, we gravitate towards looking at open source solutions, or maybe you don't have the budget. That might be a real constraint. In my experience, we give spending money on vendors way more attention than the hidden costs of building things ourselves. So if you think you need help with making a case for buying solutions, I'd be happy to talk to you after this talk or later anytime. So that's it. That was our journey, and that's what we learned. I hope this was useful, and I would love to take any questions.
The question in the chat right now, if you can go over, or I'll kind of read out for you.
Sure, just give me 1 second. Let me open the chat. All right. Yes, I will share the link to the blog post shortly after in the chat. I'll share it with you all. There was one question. Second one is from John. How do you do on-demand dev environments? How often did you have to worry about cost reduction tactics in achieving 500K spend? Okay, so 2 questions. First one, how do you do on-demand dev environments? Our specific experience was where like I said, we built a lot of glue tooling. So it was, well, Kubernetes, where you could create a namespace and essentially at a high level run a massive kubectl apply in a for loop for all the services we want to provision. And we had abstracted that with a Python script, which was further abstracted with a Jenkins job. So a developer would go say, I need a dev environment for myself. They will get a namespace with all the microservices deployed on it. And additionally, they could just specify which branches they want to deploy it for which of those microservices. This would happen roughly end to end under 10 minutes. I can share more details about this later after the call if you'd like. We've also blogged about this. That's there on Blinkit's tech blog. The second question is, how often did you have to worry about cost reduction tactics in achieving that 500K spend? That was not very often. Thankfully, we were heavily funded, but despite that, we had to sort of like, I mean, specifically in our Kubernetes journey, I remember in the span of 2 years, we had to do like massive interventions to say, all right, we're not doing anything. We're going to reduce cost 5 or 6 times. While 5 or 6 times in 2 years does not feel like too much, the problem is it just stops you from doing something more valuable. Largely the reason for that was that our cost management practices over Kubernetes were just not there because we did not have the tools for it. Right? So every time we realize that, hey, the entire cluster costs too much, now we have to go do some analysis to figure out why does it cost so much, and that would require a lot of time. Right? How often was it part of your company objectives, OKRs, every quarter for these 2 years, right? So, in a big way, right? Like, so in a big way, and for the first 2 quarters were quarters where we said, all right, we are going to run something in production, and we completely failed. But after that, we started making progress, and subsequent OKRs and subsequent quarters were more about progress and how can we speed up that progress. Right, Randir asks a question. K8s is mainly a DevOps concern, as you usually don't have to change anything when migrating to K8s cloud. Is that correct? It depends on how you look at I mean, no, actually, it does not depend. It depends on how your applications are architected. If they follow or are close enough to 12-factor patterns, there's lesser changes you'll have to make. If the DevOps team, if it does not, but the DevOps team comes up with a cluster setup that makes it hard for your developers to run their applications on, well, the developers will have to change some things in their application so that they can be deployed on Kubernetes. You can do a lift and shift, but that, in my opinion, would only work if you are closely following 12-factor principles. If you're not, you're mostly going to struggle later with your Kubernetes journey. When we say on-demand dev environment, was there an on-demand QA, UAT, everything? Yes. You could do on-demand QA environments, on-demand performance testing environments, on-demand experimentation environments. So let's say if a product team wanted to run a quick experiment, build a cheap feature by changing code in multiple microservices, we could do that. So as a capability, it was there, and then we were using it for multiple things. Abhishek asks, what strategy you guys use to implement a proper architecture for backend and front-end services? I'm not sure what is a good answer to this. It is contextual. We had multiple product teams. On the e-commerce side, or the main consumer app side, the strategy was that there was a very competent director of engineering who would make sure that all the front end and back end concerns are sort of collectively addressed by making sure that relevant participation is there from each team. But I don't know if there's a good answer. We can, if there's a specific question, we can talk after the session. And Deependra, I think we're just on time. In fact, a few minutes over. You want me to keep going ahead with the questions?
I think 2 more minutes. You can look at the question if you want to answer some of them. We'll take 2 more minutes.
Okay, so let me do a quick one. Right. Let's see.
And a question from Ranadhir about how did you address multi-tenancy concerns, isolation, security, noisy neighbors? That would be, I think.
I didn't get that. Can you repeat that, please?
Yeah. How did you address multi-tenancy concerns, isolation, security, noisy neighbors, to name a few? So I think that question you can answer, and then we'll.
Well, yeah. So multi-tenancy concerns, of course, they came up initially when, and it was largely, in our opinion, a factor of a few things. For web applications, if your limits are not correctly set up, that becomes a challenge. Again, there's a blog post on this topic that we wrote. Please reach out to me. I'd be happy to share. We ran through a big problem with respect to a multi-tenant, with respect to our web applications. Then there were separate kinds of applications that were not web applications, and they just benefited from being on a completely separate node group. So for example, Airflow jobs, right, ran on a completely separate node group. For example, all the infrastructure components like Prometheus, Grafana, etc., they ran on a completely separate node group. And then, of course, if there was a need for a particular web application as well that needed its own dedicated node group, we would consider that sometimes, but we would avoid that as much as possible. And again, these are the things that become important.
Another thing to point out here is that this tool.
I hope that answers the question, Radhir. Is there any other question that I can answer right now?
I think we're good, Vaidik. Let's keep going, and you can maybe answer on the chat as the talk is going on. That would be good. Yeah. So yeah, thank you, Vaidik. Laurent, we can have you now. So
yes, I'm here. Thank you. Yep. It was super interesting, Vaidik. Thank you. And I like your recommendations. I'm going to show you a few tricks and the audience a few tricks on cost optimization and why it's important, why it's difficult, but also that there is some hope to handle it. And I have to say, Vaidik, from your talk, I think the feedback or the advice we give to many prospects is, if you use Kubernetes, try to use it for the spirit of Kubernetes, meaning Kubernetes works so super cool with microservices, with stateless. It's fantastic for scaling up, for scaling down. And we saw sometimes some users of Kubernetes that take a monolithic application that use 60 core, 60 CPUs, and they just make a microservice of 60 CPUs. And that's not Kubernetes, right? That's just a copy paste of a monolithic thing without breaking it into pieces. And you will not benefit from extension and scaling that much when you do it this way. So, but when you do use Kubernetes for the spirit of it, so for this idea that you can replicate, you can scale up infinitely, you can use business rules to scale up, but not just when there is no more compute, but when there is activities. So it's called K8s in that case. And when you do this, you find some super, super cool things where your application works all the time. You can update one microservice, it will not stop anything, will not break anything. So that's why we like Kubernetes so much. And thank you, Vaidik, because it's nice to hear this from others and to the community. So I was really enjoying the discussion. So thank you. All right, I'm going to talk to you about when you use these Kubernetes to the letter, some of the super cool things you can do for cost optimization. Share my screen. I'll show you a few slides, but then I want to do a demo because then you see the real thing. And keep in mind that in some of the demos, and I will tell you when, there are some commercial applications of what I'm saying, but there are also a lot of free goodies that you can use. And so I will tell you every time when the goodies stop and when the commercial start. Because if I want to show you the whole thing, I have to show you the optimization side of it. All right, let's go. Yeah, my name is Laurent. I'm one of the founder of K8s. I'm speaking from Miami. And I'm so happy to see so many people in this call. Speaking out of Miami, but I go very often to India, and I will have the pleasure to come by the end of July. So it's a very dear country to me. All right, why are we talking about optimizing Kubernetes clusters and what's the frustration? Well, the frustration is this one. There are very poor utilization of resources when you deploy Kubernetes cluster. I'll show you a real example of this, but before that, these two statistics are mind-blowing. The first one says, it's from Datadog, and it says half of Kubernetes applications use less than 30% of the CPU resources they are running on. Think of this for a second. It means that on average, according to Datadog, which is independent data monitoring observability firm, they say, if you take the world, half of it pay at least 3 times more than they should on their cloud bill when they deploy Kubernetes. And the reason is because, even though your application uses less than 30% of the resources, you actually pay 100% of them. That's how the cloud works. And that's an issue we see with all users of K8s. In fact, our statistics is exactly the same on average, because we have about 400-ish organizations that use us, a few thousand applications being monitored by our engine. And we see the average is 63% cost savings, which is almost exactly the same as what Datadog is saying. 63% means the same. It's on average, users of those that are connecting the application to K8s see a 3x more expense or more cost than they should from the infrastructure on which they deploy the application. There's another statistics that's more academic, and she goes actually, Krishna goes actually much deeper. She said that 90% of applications have 5 times more resources than they actually need. And that's all for cloud native and Kubernetes. And sometimes it's very simple. So this is a screenshot of a user of us, and you can tell the CPU provision is the light line above, and the CPU request is the blue line, the blue surface below. And the space between these two is your over provisioning. It's actually 4x provisioning here. You provision 4 times more than you should. When you see it like this, it sounds very simple. This is the days of June. So in June, they could see that except maybe one artifact here, they were really over provisioning this. And it's relatively simple because you see it's a flat line. So if you redeploy this app and use 4 times less CPUs, then you're good to go, and it doesn't really move much except once. But sometimes it's a lot more difficult. So this is also, it's a real screenshot, and I'll show you the real one to prove that. I think I have it somewhere. Yeah, here. This is Grafana. It's one of our users. So you see in blue is how many CPU they provision. They're not using cast for now. So this is what they have. This was the 25th of March. And this is live data. So I just opened the screen before this call. And so you see here they have 12,000 CPUs. It's a very, very large application. It's actually in Southeast Asia. So they have about 13,000 CPUs provision, but they just use 5,700. I mean, this is a huge difference. And all the space between blue and yellow is your waste, your CPU waste. So that's the problem with Kubernetes. And this is why this is so hard to do. This application was deployed using K8s, so it's Google. So this is the best, probably the best Kubernetes can do. I mean, considering K8s is probably one of the nicer, with EKS, nicer Kubernetes orchestration platform of Google. So yeah, that's not great. And that's why it's so difficult. The difference, by the way, between the blue and yellow is about 40%. So if you could make the blue and yellow match, you'd have a 40% cost savings on this one. So that's why it's so hard to do. And I'll show you what to do about this in a second. But there are a few reasons of this. One is, first, it's very hard to understand your bill and what, in particular, AWS is sending to you. This is almost by design from the cloud providers. I mean, we can't really blame them. They manage their cloud very well. So they don't make it very easy for you to understand your bill. And this is a screenshot of one of them. It's actually our, and it has already 33 pages. So it's very, very hard to understand anything you can from whatever they send you at the end of the month. The other reason why it's hard, and you guys said it very well before, is you have, as a developer, you have to, or DevOps, you have to reply to so many questions, and all these questions are completely interdependent between them. So when you deploy an app, usually the first question you have is how many nodes, how many VMs, it's called a node in the Kubernetes language, how many stuff I need, how many machines I need. But it's not just that, it's also how many containers, how do they scale up, what's the rule of scaling up, and of course, what should be their size. So you see, this is why it's so hard to handle cost optimization for Kubernetes. You have all these questions, and the answer of one will almost dictate very, very clearly the answer of the other two. So usually you start by the pods, you start by sizing them, how many CPUs and memory they request, what is their limit, but then you have to think of, hey, when do I duplicate them? So using HPA, horizontal pod autoscaler, or KEDA, which is my favorite one. So you kind of see their side. Sometimes you use VPA, which is a recommendation engine from open source that will tell you what should be the memory and CPU requested for each of these pods. So that's VPA. But when you answer the question of these two, then you have the third one, which is, okay, once I know how big this is and how do they behave, how many machines do I need? And the problem with this is if you select very large machine, then you're going to have a trouble reducing them because they will all be busy. If you have a 60-core machine that is busy 15%, well, you can't really take it out because it is still busy. It's just busy only 15%. So you have a lot of space on that machine that is not so well used, but you're paying for it. So you see, answer of these questions are all trade-offs that are almost impossible to solve if you try to do it by hand. And that's why this is so hard. So I'm going to show you examples of this and what to do about it. I will do it for real. So I'm going to deploy. So I created a cluster a few minutes ago on EKS. What I'm showing to you is an open source tool that is very nice to visualize the cluster. So this cluster has 6 nodes. There's no containers yet. These green things are the containers, the pods. The only one that is there is the one that EKS is adding, which is a daemon set. So for now, the cluster is empty. I haven't deployed my app. I have 6 machines. They're all M5, typical popular machine on Amazon. What I'll do is I'm going to deploy an application on it. So I use Lance, yes, for my terminal. I go to my app. I'm using Boutique, which is an open source app from Google. And I just do my kubectl apply for everything. So I'm deploying the app on this cluster that has 6 nodes. And yeah, it's happening now. You see all the pods are coming. And if you go here, you probably will see, yeah, the pods are being deployed. One thing you see here is I selected 6 nodes, and that means Kubernetes is a fair engine. So it's gonna deploy in evenly. So it's gonna try to make all these machines busy in the same equal ways. We call it a fair system. When you deploy containers, it will spread them evenly over all the machines you have in your cluster. And so that's exactly what happened. It did select the orchestration engine selected, or EKS selected where all these containers should go. And you see the problem here is what I said earlier. This is the CPU utilization, and yeah, it's not great. So it's less than 50% everywhere. That's one of the issues of Kubernetes you see just right now is, well, I didn't know how many nodes I needed, so I use 6 because why not? It's more than 5 and less than 7. And I use some popular one which are called M5, and yeah, they have 2 cores. And as developer or DevOps, I just deployed it to see what's happening. And you can see the job is not very nice. So I'm going to show you now what an engine would recommend instead of what I just did. So this is, I'm going to show you a little bit of Castella now, but what I'm showing to you is a free side of Castella. So you can use it for as much as you want. So this is Castella. What I'll do is I'll connect this cluster to my engine. So we have versions for EKS, Google, K8s, and K8s. If you are planning to choose one, don't take this one because it's not managed. You know, Azure, Google, Azure maybe not. Google and EKS are the best one. But to connect is very easy. It's just a script. So I take that script, I go into my terminal, I run the script install an agent. It's very similar to Datadog. The agent goes inside. It's like a container within all the other containers. Here it comes. And that agent is starting to collect information from the cluster. This information is coming back to our central engine, and the central engine is gonna give you some interesting cost reporting and cost recommendation. Again, this is entirely free. That's why I'm showing it to you. So the engine is inside, it is within the cluster, it's collecting data, it's sending the metadata to our mothership. The metadata is very, very simple. How many containers do I have? How many workloads? What do they need? How much CPU and memory they request? Where are they deployed? How many VMs or nodes? How much they spend? How much they cost? What's their capacity? How many CPU and memory? So all this metadata. The agent doesn't know what the application does, but it just knows the application have a bunch of containers that do a bunch of things on a bunch of machines, and is collecting that information and some of the cost. This information comes into a savings report. Savings report is telling you you're over provisioning, and you kind of knew about it because it wasn't great here. This is CPU utilization. So that's why it says, yeah, you in fact are overpaying that thing by 60%. Again, this is entirely free, so you guys can use it for as much as you want. And it tells you why. So I had these 6 machines, they were M5, so typical on AWS, and it cost me $420 a month. And the engine says, you know what, for what you do and for what you have, instead of 12 CPUs, you could use 6 only. And instead of 48 gig of RAM, you have a 4x of a provision on memory. Because 12 is more than enough. If you do all this, then your costs go from 420 to 167. And it actually gives you some solution. It says, look, instead of having this 6 M5 where you have 12 CPUs, why don't you have only 3 of them of C6A that have only 2 CPUs, and therefore you reduce by half the number of CPUs compared to before. But there's another thing. You see the cost reduction is more than half. It's 60% because you also don't need that much memory. So this C on AWS means compute optimized, has less memory per core. So it's 2 gig for 1 CPU. Here it's 4 gig for 1 CPU. So that machine is actually more cost efficient because it has less memory. But the other thing the engine says is the following. This letter A is very interesting. A means AMD. And this is a typical thing we see almost everywhere. AMD on AWS is about 6% cheaper than Intel, have the exact same performance, almost. than Intel. So you can compare these two very well. So what this says is, look, I, as DevOps, had no idea, well, I didn't know kind of what machine I use, so I use the one I know very well, which is an M5, and the engine says, you know, M5 is great, but yeah, if you use a C class, you have less memory per core because you don't need that memory, that's fine. If you use an AMD processor, you're saving another 7% or ish of your cost. On Google, it's almost exactly the same cost reduction. And therefore, even though you have your cluster in size, you save more in percentage because you select machines that are cheaper than an Intel processor. So that's what this does. It does something else too. Like we have this toggle that says, hey, maybe you can use some spot instance. And what happens if you do? So if I click yes here, then the engine does something else. It says, well, you have a bunch of containers here that have a lot of replicas and they are completely stateless. Not all of them, but the engine knows that they are. And therefore it says, you know, all these containers, they are actually friendly. We call them spot friendly. So they are friendly to use discounted VM called the spot instance on AWS, and Google and Azure have the exact same thing. And that will give you another 15% savings. So if you follow the recommendation now, this is a lot more interesting than before. It says, well, I kind of need only one on demand because the rest of my workload can go on spot. And I found a spot instance that is really inexpensive right now in my region. I think this is using US, I think it's US West. It's Oregon, I think, US West 2. And it says, yep, if you're okay with spot instance, if you're okay with using them, if you click here and you get the list and you're okay with the list, you would really should be spending only $102 per month. Because this application is stable and doesn't move much, you can use this as a great recommendation. You recreate your cluster, you select these machines, you redeploy the app, and the app will work the exact same way, but it just costs you 4 times less than it did in the beginning. That's what this report shows you. And then there is other things, other goodies. We included some cost reporting. So this is the cost per day. You have here the normalized cost per CPU. This is interesting because it tells you how well you do in selection of machine. So the most expensive one on AWS are in this $35-ish range. But if you start to use spot instance, you will see your cost per CPU going down because spot instances are a lot cheaper than on demand. And so, yeah, so this cost reporting is something that is completely free. You can use it. It's kind of similar to KubeCost, but it will tell you where you spend money. You can get this by workload. I just deployed the app. There's not much there, but this is your cost per workload, so per type of containers. As you know, oh, my recommendation service is costing me 0.6 cents right now, which per hour is 0.48. And then you can do the same by namespace here. So I have one big namespace that is not great because it's called default. Don't use that. And then I have my kube system and my K8s agent. So you see how much my K8s agent is costing me for this cluster. So all of this is giving you some visibility into how much you spend, and it's also giving you a recommendation of what to do if you want to reduce your cost. Now the thing with K8s, and I'll just show you briefly some other things, is once you have this recommendation, we have built the engine that will move from $420 to $102. So this is the commercial part of the product that says, yep, if you like this recommendation engine, and if you like the cost reporting, sorry, someone is talking. Oh, okay. So if you like this cost reporting and this recommendation and you want to realize the savings, if you click on Start Saving Now, there's another script that will do a read and write on this application, and you will start to have your cost reduction that will go into the order of 102. And this is something that works in real time. So in real time, your cluster will be optimized. Just want to show you an example of it. So you see what happened the before and after. So remember, this one was before optimization. So you'll see the blue line is CPU provision and the yellow is CPU requested. The difference between these two is your waste in terms of CPU utilization. And I'll show you a Grafana of after, which I just bookmark. And this is the after. Let me take these two things. And this is the after. So you see the difference between these two. This is before. So before using an engine that is trained to do cost optimization to this one. And this one means the blue line follow a lot more closely. The yellow line, it means my cluster is extremely well optimized in real time. And the key here is to think of this as a real-time engine. So if you look at the cost reporting I was showing to you before, this one here that shows recommendation, once you activate this, then you'll have an engine that will fiercely analyze this every 15 seconds and change and optimize your cluster so that you are always in that situation here. Even if the cluster increase, the engine will try to do the autoscaler up and down in a way that you follow as much as possible the utilization curve. And this is what you get in this case. So that's, but that's more the commercial part. So I don't want to emphasize that too much. It's for you guys to think of, but just keep in mind that if you have questions about your cost, run the agent the same way, exact same way I just did. It's very easy, very simple, it takes a minute. You'll get this report. It will tell you if you have reserve of optimization. It's a real-time report, so you can open it every hour if you want. You'll get different configuration if your cluster has changed, and it will tell you what to do about it, but that's a manual process. Cost reporting is something that will tell you your cost evolution over time, so you can use this. You can download this, you can use this in Grafana. These things that you see here is exactly the same as this. It's just a different view of the time series that we use for cost reporting. And this time series is available. So you can use UI for free, or you can use Grafana for free if you want if you prefer to use something like Grafana, which I really personally really like. So once you activate the engine, you will get in that state all the time, up and down. And that's what happens when you optimize it. You'll try to fit this as much as possible. But I want to share with you something. This is very, very hard to do manually. That's why that's the best you can get with GKE. It's very hard to do manually because look at the sheer number of CPUs that goes up and down. And the difficulty here was, how can I reduce the size in real time? So in few seconds, how can I reduce the size of that cluster in real time as fast as I can, even though these numbers are giant numbers. And the steeper the curve, the more cost optimization you will have, because steeper the curve means you can follow the utilization a lot more than what the standard autoscaler can do. So the standard autoscaler is very hard for the autoscaler to go down more than this. A smarter version of this is able to handle it a little bit more. The difficulty of doing this right sizing, and I'll finish there. The difficulty here is, it's not like, oh, I have 1,000 servers and 200 of these are not used. No, they are all used a little bit. And so how you do right sizing here is you have to do some very clever bin packing where you have to analyze, okay, which of these 200 servers that are nodes that are not very well used, can I move the pods around? Can I empty it? Can I bin pack it? So I take all the containers, all this rectangle you saw before, can I move them around so that I can empty a machine? But can I do this a few hundred times per minute? Because that's how steep that curve is. And can I do this without any outage or any performance impact on my application? And so this is why what I was saying earlier in the call was important. Yes, you can, as long as you use Kubernetes for the spirit of it. Meaning, if all of these containers are fully stateless and have a high replica, then yeah, you can move them around because they are designed to be moved around. But they are stateless. They can go into a different machine. They work the exact same way as the first machine they were on. And this is what our smart engine is recognizing. It looks like at all these highly replicated microservices and says, well, this microservice is on a machine that is only busy 10% of the time. I'm going to move them around because I can empty that machine. And I know that these microservices are so well replicated, they can move around without any performance degradation because they were designed to be moved around. And that's exactly what this engine does. When you do this every few seconds and you do this 100 times per minute, then that's how you effectively follow the curve between utilization and provision. And as you follow the curve, you effectively save a lot of money in between, right? Remember, this difference is between here and here is 40%. The application is the same, like nothing has changed. It's just that you pay 40% less when you do it this way. And then the last thing I want to say is, let's make a zoom of this. So you see how it's reactive, right? In about 2 minutes, we add new nodes. This goes down, then it goes up again, we add new nodes. Then here, there's no more need of this. Then we go down as fast as we can, et cetera, et cetera. Here, there is a little bit of go up. So we go up, but we don't go up very much because this is so short. Then we start to go down almost immediately, et cetera, et cetera, et cetera. This is how the zoom on this would look like. And again, you can do this only if you are true to the spirit of Kubernetes. So that's all I wanted to share with you. If you guys are interested, please contact me, contact my colleagues on the call. It sounds difficult like this, but it is not, because it's a one-click button type of solution that will analyze your application in real time, but you don't need to be a customer. And I want to emphasize this. Run this savings report, use us for cost reporting. KubeCost is also actually a very good solution to do that. Use KubeCost or use Cast.ai for your cost reporting. It's free, it will be free forever. We'll do data retention so you can look at last month, last week, last quarter, and that gives you a little bit of insight on your cost. So that's what I wanted to show you. Thank you for time. I think there is a few questions that I can reply. And if you guys have questions you want to speak now, it's nice as well. It's hard to know which questions are there.
Yeah, Laurent, there is a question for you.
Yep.
The first question is, how interactive is the agent for making the changes that you are showing? And what insights, apart from cloud specific, would it provide over the autoscalers in Kubernetes, like the HPA and BPA?
Yeah, so I didn't show it to you because I was more commercial, but I'm going to show it to you. You'll see the agent is effectively replacing, I think I have one here that is live, this one. The agent is effectively replacing your autoscaler. So when you use it as in activation mode, so in cost optimization mode, you make this kind of decision. So you influence how you want the agent to make changes. And the changes are made all within or inside your cluster. So for EKS, GKE, or KS, and you just do it like this. You say, well, I want to use spot instance if I can. So if my containers are spot friendly, you click here, and that means every time there's a scaling up, I will replace this much, or we use spot instance because my containers are friendly to it. There's a few other things. Here, for example, says if my cluster is empty, please run some aggressive right sizing. This is what I just did now. If I click on apply, then I'll have the right sizing works in real time. I will try to use my thing. So the agent is inside your cluster, and in read and write, it starts to make change based on some message board or message that it received from our mothership that is doing this analysis. It is, and to finish the question on autoscaler, it does fit HPA and BPA in the sense that it follows your application. It's not replacing it. It doesn't replace anything in your app. When it sees that there is a scale up event, so when your HPA is scaling it up, it will add a new node, but it will add the right one. Not the one that was there before. It will say, oh, I need a new node for 25 CPUs. This is the lowest cost option, considering what are these workload that is given to me by AWS for this node to be added. So it follows your HPA and BPA guidelines.
So, like if I were to rephrase it, are you saying that the Cast.ai agent is effectively a scheduler which replaces the built-in scheduler.
Exactly. It replaces the autoscaler of EKS or GKE or EKS by a smarter version of it. And it's one autoscaler that is a lot more cost aware than the one that comes in standard. When I say it replaces, there's nothing to do, right? When you enable our agent in read and write, it automatically takes over the management of the nodes on your behalf. And so it is still EKS in the background. The difference is we give orders to EKS to do certain things. We don't replace EKS, we just give orders to EKS to do certain things according to optimization.
Right. Okay.
Yeah. Oh, there's a question about Castella work with Fargate. Does Castella work with Fargate? This is on AWS. Fargate is a kind of serverless node. The short answer is no. And the reason is because it does a better job than what Fargate does. So Fargate is a serverless option where you don't need to manage your nodes anymore. Fargate does it for you on EKS. The issue here is Amazon makes you pay for it. And so Fargate becomes an expensive solution. It's not the main problem though. The main problem of Fargate, in my opinion, is more cybersecurity. Fargate means that this VM on which your application works on are going to be shared by other customers. And the problem in Kubernetes is containers are a very light separation. The containers are very lightly separated between each other when they run on the same machine. Kubernetes was not designed for cybersecurity. It doesn't have the strongest separation as 2 VM, for example. So 2 VM on the same hardware are much more separated than 2 workloads on the same VM. And that's why I'm not a big fan of Fargate. And there's another question about ECS. Does Castella work with ECS? So ECS is a kind of the legacy orchestration platform for containers of Amazon. And the answer is also no, because we felt that Kubernetes is probably the way to go. And so we are a lot more excited by EKS than we are by ECS, which is the first attempt of AWS to manage containers. If you use ECS, that's great, but I really think you may have to consider moving to EKS instead. It's open for debate, right? I'm not the only one. There are good and bad things for both sides.
You have another question for you, Laurent. Is this only for compute costs? And how about reducing storage and networking costs also incurred in cloud?
Yeah, it's a great question. So in the cloud native world, there was a survey made by CNCF. It shows that your cluster cost, your Kubernetes cost, 90% of that on average, according to CNCF, is CPU and memory. In fact, CPU is 80% and memory cost is 10%. That's the average according to CNCF. But storage is the next, and storage is around 7% cost. And after storage, you have a bunch of small things like egress. So yeah, we only do compute that include memory. So it's about 90% of your cost on average. But yeah, stay tuned for storage. I can't say it more, but yeah, it's a good point.
One last question, Laurent. Are the nodes recommended by the Castella engine all dedicated nodes?
Yeah, dedicated in the sense that yes, there are VMs, there are nodes that are only yours. And so the answer is yes, absolutely. If you optimize by Castella, you will see your I'm trying to show you. Yeah, you will see your M5 being replaced over time. I did it a little bit fast, but you can make this replacement all at once, or you can make it over time. The one I'm showing to you is a replacement all at once. So if I click on rebalance, my cost, I have 5 M5. My cost will move from 5 to 102. So in this case, it will replace all the nodes at once. Once you do this at once, this is a maintenance phase. You do that maybe once a week. The autoscaler of Castella will make sure that in between the time you do rebalancing, you will keep the blue line and the yellow line, the utilization line, as close as possible. So I'm doing it now, but it will take 2 minutes. We'll not have time to finish. But yeah, this is exactly what a customer would do. It would rebalance it up. So here I'm replacing my old nodes by new ones, and you see 29 seconds ago, the new ones are coming. And the old ones will be deleted once the new one are there. So that's how it works. All right, thank you so much, guys.
Right, thank you, Laurent. Thank you, Vaidik. So it's a great session, completely kind of mesmerized by the topic and the content what you guys have delivered. So I think all the participants would have really enjoyed it for sure. The recording of that would be available on the meetup page. We'll put it maybe in a day or two max, and we'll put the slide deck also what we get from both the speakers. So hope you like the session, and yep, that's all I believe from our side as well. Unless anybody has any burning questions, otherwise we'll just sign off for the day. Yep. Okay. Thank you, Laurent, Vaidik, for this time. See you soon.
Bye, guys.
Bye.
Thank you. Bye.
Thank you so much. Bye, Nipendra.
Bye.
It's a pleasure speaking.
Bye.
Thank you. Bye-bye.
Thank you.
Thank you, everyone.
Yes.